Have you heard of the dark side of the moon? It sounds spooky, right? But what if I told you it's not actually dark all the time?
That's right. It's a bit of a misleading name. It's actually called the far side, and it gets just as much sunlight as the side we see.
So what's the big deal then? Why all the mystery?
The far side is super different geologically. Think of it like comparing a smooth beach to a rocky mountain range. That's the difference between the near and far sides of the moon.
Wow, a Rocky Mountain range on the moon? That sounds amazing. Let's dive into the details. So why do we only ever see one side of the moon?
It's all about something called tidal locking. Imagine you're spinning a basketball while holding it. If you hold it just right, it'll only ever show you one side. The Earth's gravity does that to the moon.
So the moon is basically stuck showing us the same face?
Pretty much. It takes the moon about 27 days to spin once on its axis, and that's the same amount of time it takes to orbit Earth. It's like a perfectly choreographed dance.
A cosmic dance, I like that. So even though we only see one side, the far side still has day and night, right?
Absolutely. It just means that when it's daytime on the far side, it's nighttime on the near side, and vice versa.
Okay, so let's talk about the differences between the two sides. You mentioned a Rocky Mountain range.
The near side is mostly smooth, dark plains called maria, which are basically giant solidified lava flows from ancient volcanoes. Think of them as giant dark puddles.
Giant dark puddles, that's a fun way to put it. And the far side?
The far side is mostly heavily cratered highlands. It's like a cosmic battleground from billions of years ago. Lots of impacts, lots of craters.
So one side is smooth, the other is bumpy. It's like comparing a pancake to a popcorn ball.
Exactly. And that difference is a big mystery scientists are trying to solve.
Why are the two sides so different?
There are a few ideas. One is a giant impact early in the moon's history. Imagine a huge asteroid hitting the moon that could have really messed things up.
A cosmic fender bender.
Exactly. Another idea is that Earth's gravity and heat played a role in the distribution of materials and volcanic activity.
So Earth might have influenced the moon's appearance?
It's a possibility. And finally, there might be differences in the moon's composition itself.
So it's a bit of a detective story trying to figure out what happened. How did we even discover what the far side looks like?
It was a big deal. The Soviet Union's Lunar 3 mission in 1959 took the first pictures. They were grainy, but they showed us a cratered landscape.
Grainy pictures from space. Ah, that's amazing.
Then came the Apollo missions, which gave us much better views. And more recently, robotic missions like the Lunar Reconnaissance Orbiter have given us incredibly detailed images.
So we've gone from grainy pictures to high-definition images. Ah, that's incredible progress.
And in 2019, China's Change 4 mission even landed a rover on the far side.
Landing on the far side must have been incredibly difficult.
It was. The biggest challenge is communication. The moon blocks direct communication with Earth.
So how did they communicate?
They used a relay satellite orbiting the moon to act as a middleman. It's like having a friend pass messages back and forth.
A cosmic messenger service.
Exactly. It's a testament to human ingenuity.
What can we learn from studying the far side?
A lot. The far side's cratered surface gives us a better record of early impacts in the solar system.
Like a cosmic history book?
Exactly. And the South Pole-Aitken Basin, a giant crater, can tell us about the moon's internal structure.
So it's like digging up clues about the moon's past.
And because it's shielded from Earth's radio waves, the far side is a great place for radio astronomy.
What's next for exploring the far side?
More robotic missions, sample return missions to bring back rocks for study, and even the possibility of building radio telescopes there.
Radio telescopes on the moon? That sounds like science fiction.
It's becoming science fact. The far side is a treasure trove of scientific information.
It's amazing to think about all the discoveries that are still waiting to be made. So even though it's not always dark, the far side still holds a special place in our imagination.
Absolutely. The mystery, the challenges, and the potential for discovery make it a truly captivating place. It's a reminder that even our closest celestial neighbor still holds secrets waiting to be unveiled.
That was a great discussion. Thank you for explaining the mysteries of a lunar far side in such a clear and engaging way. It's amazing to think about all the discoveries still to come.